I am so I got a lot of, so I posted that announcement, so first off, about like how many of, like asking, okay, who needs extensions? And that was mainly so I could get a count. Um, and generally what I do is I multiply by 4 or 5 to figure out how many students need an extension. So that's generally the way I figure out how many students need an extension. I just multiply the response rate by 4 or 5, and because I figured that's combinations of students who are too busy or haven't even started yet. So I extended the recursion lab until Friday. That's not going to prevent me from posting the new homework on Wednesday to start going over trees. Now, when will you have to know how to apply that stuff? So not this week, but next week on the 25th and the 26th will be the next time. Will probably be the next time lab, and that will go over trees and heaps. Now this one is this one's actually going to, in my opinion, going to be a bit easier because some of this stuff will be directly answerable just by looking at the slides. I think there's literally 30 points of material that you can answer just by going and getting an equation from the slide and putting it in. And the trees will cover recursion. And as I've mentioned before, if you understand, all you have to do is master the 2 different methods. The zigzag method that I've been talking about, which is really, really easy, and then the traversal method. And honestly, most of the questions you'll be asked will have to do with one of the traversal methods, doing an in-order traversal, pre-order traversal, or post-order traversal, which all of those are 3 different algorithms, but as I've pointed out in the video, it's just simply the order in which you do the processing. It's the same algorithm, it's just what order are those lines in. And as a result, if you master those, you're golden, because those problems take basically about 4 to 7 lines apiece, including the braces to do about. So, yes, assuming you don't screw it up. So there will be the next time lab then. Your next exam, so that's week 9. Your next exam probably won't be until week 11, so you've got plenty of time there. So it'll be before the winter break. I'm sorry, the fall break. Obviously, it'll be before winter break. So there's that. But your next exam will cover. Just to let you know, it does cover less about stacks and queues. They do make a slight appearance there, but mainly as like. I have a page now that you've learned a bunch of data structures that will be like, which is the appropriate data structure to use in this scenario? And I always have a question that can be answered by a stack or a queue in those. And then a lot of it's going to be focused on trees, and if I feel like it's appropriate to include it, there's going to be a question or 2 about hash tables. So, because that's what we'll do after this. So next week we're going to be focusing on heaps, which will be on the timed lab. So I'll be putting up those videos fairly soon, so you'll be able to watch them. But heaps will be on the timed lab. The Huffman encoding, which I'll go over, will not, but it will be on the exam. And Huffman encoding is always on the final exam. So now that's abstracting in the future. As I said, I want to go over the 8 queens problem because that is right now seeming to be a point of contention for a lot of people. Sudoku is actually, I'll give some hints on Sudoku, but it's not so bad. So the first thing is that I'll be blunt. At this point in your life, you're probably terrible at figuring out what order to write things in, because and that's just simply because most of you are probably only started coding in college, which means you've got max 2 years under your belt, max, for programming, and so I'm going to go over the chess problems and kind of just show you where I would start with this. And the answer is, even though I have this nice algorithm that says, hey, I want to solve this problem, we're going to start with the valid choice. We're going to start by coding up the valid, because that's a testable, easy to test portion. When you write code, you always want to write parts and chunks that you know will work, simply so you can start gaining momentum. Right, so that basically you don't feel like you're clobbering your head against something. So you can give yourself basically the sense that you've actually managed to get something done. So now but first, one thing I want to do, even before we start coding, before we start doing that, you want to make sure you understand the code. So the first thing I will do is actually, I'm going to run through this recursive backtracking algorithm on a 4x4 chessboard, right? So instead of doing an 8 queens problem, I'm going to do a 4 queens chessboard. I'm going to do a 4 queens problem on the whiteboard, right? Just to make sure I understand how it works, right? So as I mentioned, I assume you've all watched the video by now, but as I mentioned, what we want to do is consider only one queen that can be placed in each column. So we can simplify the problem by asking, for this current column, what row can I put a queen on? So that means that position in this case will be column, right? So first off, if a column is such that I have nothing left to solve. So in other words, I'm going to try to solve column 0, then 1, then 2, then 3. Once I get to column 4, or in this case, board.length, I'm done. I'm just going to terminate, return true. And as we'll see, that will send a cascade of calls that will solve the problem. Next is for each possible choice. So what are my choices? Well, I'm considering putting the queen in each column. So my choices are the rows, right? So for each possible row, if it's a valid row, I'm going to mark the board at the position with this choice. And honestly, there should be an unmark over here as well, in case that doesn't work, but it depends on the algorithm that you're using. This one was kind of what I took from Sudoku and then applied it. So anyway, so if it's a valid choice, so what I'm going to do is now run through it. So is this a valid place to put a queen? Yes, there's no queens in this direction, or this direction. Why do I only check those 3? Because I know if I'm placing one queen at a time, then in one queen per column, well, by definition, I'm putting one queen per column, so I don't need to check the column for other queens. Furthermore, if I'm placing them from 0, 1, 2, 3 in this direction, then there aren't going to be any queens already in this direction, right? There's going to be nothing in front of me. So the only directions I have to check are this direction, and this direction. Okay? Which of course means now I can redraw my entire board. Yeah. Okay. So that was not the smartest move, Andrew. All right. So next. So is this a valid place to put a queen? Yes, it is. So we put a queen there. Okay. Next we go. So now we call that recursive solve method. So if solve board pos plus 1. So call, so 0 plus 1. So we're going to be solving it for column 1. So now we're in there. Am I in a position that there's nothing left to solve? No, I still have a queen to put here. So for each possible choice, can I put a queen here? No, there's a queen that way. Can I put a queen here? No, there's a queen that way. Can I put a queen here? Yes, this is a good place to put a queen. Okay, moving on. So so now I call recursively if solve board, and I can't even evaluate that if statement yet because I still have to get an answer back. So I'm going to call solve on board 1 plus 1, so column 1. Sorry, column 2. Can I put a queen here? No. 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 So so I went through all possible choices. Make sure that there's not going to be any choices. I don't have any queens left on this, right? That there's nothing left that will mess up my answers in the future. And then I return false. So now inside the solve block for column 1, if solve board plus 1, so solve board 2, just return false, right? So in that case, I guess I have to pick up my queen and move it on. So now I check this square. Is this a valid place to put a queen? Because they still had a valid choice in the for loop, right? I stop that if statement. I go into the next part of the for loop, right? I increased my row number, so I'm going, oh, is this a place I can put a queen? Yes, it is. So I put a queen down there. Can I put a queen here? Yes. Can I put a queen here? Sorry, can I put a queen here? No. Can I put a queen here? Yes, I can. So I put a queen here and call final order. I can't put a queen here for that. Can't put a queen here for there. Can't put a queen here because that diagonal. And I can't put a queen here because there's a queen over there. So this won't work, so I return false, which means that he got false back for his call to the next guy. So he has to pick himself up. Can I put a queen here? No. Can I put a queen here? So he returns false. So So now, solve board 4 just returned true. So solve board 3 is going to return true, which means solve board 2 is going to return true, which means solve board 1 is going to return true. I actually shouldn't erase these guys, but solve board 1 is going to return true. Solve board 0 is going to return true, which means that we just got true back. So which means that the original method call returns true. Yes?
My biggest issue on the chess question, the 8 queens, was the valid.
Yes.
The valid choice.
So that's where, so now that we've got the understanding of how this works, we want to work on valid because valid can be tested without any of the other stuff. That's why. Because we can test valid as an independent unit. So let's,
Does that mean valid was valid supposed to be a separate method?
yep, valid should be a method on its own, right? That's why it's got a call, a method call like that is valid choice. So let's go ahead and write that, or I'm going to start showing you how I would write it. Public static Boolean is valid. So what would I need to, what information do I need? I need integer, and I'm recording this in case you miss it, in case you need to refer back to it later. Int board, int row, int col, and that's sufficient for the 8 queens problem. For the Sudoku problem, you're probably going to want to include like what number you want to enter at that row and column. For here, it's just sufficient to say that we want to put a queen there. Now, by default, I'm just simply going to return true, saying that, hey, this is perfectly valid, right? I can put a queen there, right? I'm gonna assume it's a valid place to put a queen until I'm proven otherwise, right? Now, there's 3 things I have to check, right? I have to check the same row. The same row. I have to check my upper left diagonal and my lower left diagonal, right? Those are the 3 directions I have to check. So it's best if so I've seen everybody do it as 3 separate statements, different checks that they try to do. It's easier for me if I just simply do it as I do it as 3 separate methods that this calls. Is row valid? Pass in the board row call, return false, and then I'll just start over here. Yeah, I'll throw it into an if statement. So if it's not valid, if the row is not valid, right? If it's not a valid row, I'll return false. So that means I need to program that. So public static Boolean is row valid, which will take in which will take in the exact same things that we took in over here. And this is just simply so I can have individual pieces to check, right? Individual methods that I can easily check. And again, what the assumption is that I'll assume the row itself is good, that there's no other queens in this row until I'm proven wrong. So I'm going to start this my for loop in a bit of an interesting way that you're about to see, which is you're going to see that basically it's going to be a bit different. It will make sense. So for int I is equal to 1, then it's not going to be I, but I'm going to do this. So greater than or equal to 0, col minus I. So int I is equal to 1, column minus I is greater than or equal to 0. And because what do we do to check to check that there's nothing in the same row? We modify what column I'm checking, right? So now here what I do is I say if board row column, and I found this through a lot of experimentation and figuring out that this was like the cleanest way to do it, is equal to 1. So if there's a queen there, return false. Oh, and column minus I, right? So here, your main issues with checking for validity is going out of bounds, right? Because essentially you're given a square, right? You want to check basically you want to check into all the columns. I start at row column, and I then, or basically go away from there. I start at row column and then I go away from there. Instead of trying to work towards it, I work away from it until I get out of bounds. And so this keeps me from going out of bounds, this statement over here. Column minus I is greater than or equal to 0. And then later on, and my hint for checking, for trying to do two directions at once, because right, when you're doing the diagonals, it will be plus row or minus row as in addition to the column, right? You can make this check over here as complicated as you need it to be. You can, in fact, put in an AND statement over here, right, to make sure that two factors don't go out of bounds. So that's my hint to you for the rows. But for right now, this is all I'm going to code up because it's sufficient enough for me to test that certain things work, right? This is actually a testable portion that I can get started with, right, to make sure that this works, okay? Public static void main. So if you're working in NetBeans or in IntelliJ, you can just type PSVM and hit tab, and boom, that's how that magic works. So now we're going to make our chessboard. Int board is equal to, and this is actually the most tedious part of it, I'm going to create a, so 1, 2, 3, 4, 5, 6, 7, 8 squares. Copy, paste, 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 paste. Whoops. Like I said, the most tedious part of it. Paste, 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 paste. And that's an 8 by 8. And then it's giving me an error over here because, of course, I do need to terminate the line. That was on, and I'll just move that over here. And there's my 8 by 8 chessboard, right? Yes?
So, would this just like visualize
Yes, you can do it.
an array of
So there's a reason I can do this. I do it like this because now I can put a 1 here or a 1 here and check my is valid method. That's where I'm going with this. But yeah, you can do it that. But I like, if I'm dealing with a graphical board, I like to do it a bit graphically. So now what I can do is I can put very simply, I can test my is valid method. Put a 1 here, a 1 here, and let's see, a 1 here, right? And then you can start testing it, right? We know that basically if I'm in, so let's go ahead and print is valid. Let's go with board, row 0, column 5, right? Row 0, column 5, so that's row 0, column 0, 1, 2, 3, 4, 5. So this should return false because there's already a queen in this row, right? There's no queen in row 2, however. In row 2, however, it's completely clean. So we'll go ahead and run it, and that should return true. Right? Row 1 should also return false. Right? So now we can discretely test that. And so now you can add on to your is valid checks. Right? You can then say, and not is valid, like is upper diagonal valid, right? You can do a check like that and then work on the upper diagonal and test just that, right, is the point. So you can build up from there. But this is actually enough for us to do the recursion, right? Because what we can do is we can test out, right, a recursion that would go, okay, I can put a queen here. I can't put a queen here, but I can put a queen here. I can't put a queen here or a queen here, but I can put a queen here. And it wouldn't be a correct solution, but it would at least let us know that the solve method is working, right? It would be like the 8 rooks method right now, and then we can use coding the diagonals for the 8 queen. One last thing to note is that, again, this does exactly what you tell it on the tin. So if I tell it check is valid row 4, column 3, which is this square, it's going to return true because because even though there's a queen right here where you want to put it, it's going to go this way, this way, this way. That's just simply because we assume there's not going to be a quiz where we're starting, so I don't bother checking that square, right? So, all right. So now let's go ahead and see how we use the solve method, right? So I'm just going to grab this, yoink, copy, and paste, right? Now everybody freaks out as they try to keep up with me typing, right? So public static Boolean solve, we need an int board, right? It's board int position. What's my position? It is column, like I said, right? So public static Boolean if col is such that there's nothing left to solve. So if column is greater than or equal to board.length, right? In other words, if the columns is out of bounds, we're assuming, of course, that for simplicity's sake, we're assuming the chessboard is a square chessboard, right? So I can use board.length to get both the number of rows and the number of columns. We return true. So now that we know that we're not out of bound, for each possible choice. So what are my possible choices? Well, those are the rows. So what are the possible values for rows? Int row is equal to 0. I is less than board.length row plus plus. And here we go. So if it's a valid choice, and I think I called the method isValid. So how do I use isValid? Well, I have to pass it it's not I over here, it's row. If board row column is valid, then I have to mark a board at position with that choice. In other words, I put a queen there. How do I put a queen there? By putting a 1 there. So if it's a valid place to put down a queen, I put down a queen. Right? That makes sense to everybody? And then I just simply solve the board and the next row on the board. Sorry, the next column on the board. And if that works, then I return true. Else, then I need to pick up that queen. Right? If I put down my queen and it doesn't work, then I should pick up that queen. Other times you can just overwrite what's there, but here we really need to pick up the queen when we put down a queen and it doesn't work. Again, that depends on the problem. So we just simply say row column is equal to 0. Clear any choices. We already did that. We did that inside the loop. Return false. And so now, if I run this code, right, and let's go ahead and get rid of these 0, 0, 0. Let's go ahead and do, so let's call solve the board, starting at column 0. And then we need to print out the board, which is actually easier said than done. So for each int row in board, sout arrays so arrays, which is going to be something from java.util you'll have to import, .toString the row. So we'll print out all the rows like that, and now we can run it. And there, as you can see, we don't have a solution yet, but we have something what we'd get, which is since we're checking only that the rows are valid, right? Since we're just checking to make sure is this particular row is valid, we can, we would only get we'd get a diagonal. So if I start this by putting by starting it at the next column and putting a queen over here, that's going to actually change my answer appropriately. Give me one sec. 2 processes running. See? 1 over here, and then it goes down diagonal, and then it says, oh, I can't put a queen here, so I put a queen here, and then I put a queen here, right? So it skips over that other row appropriately. So that's pretty cool. So this is a way that we test, and now we know that basically that so the point is that with the way I wrote it, at every time I was kind of making sure that other pieces of it were making that the big chunks that I had done were working, right? I tested it, and then I tested to make sure that recursion is working, and so now I know what I have to add is the diagonal methods, right? Which of course I have to leave some of that for you. Normally I don't go into too much detail, but I saw that students would find it I thought you guys would find it very helpful to do so, since a lot of you were having trouble getting started on this, and this will help you also get started on Sudoku. Now with regards to the Sudoku puzzle, that one's a bit, I found, again, you want to start by coding the isValid method, right? But you don't necessarily need to code all of it at once. I might just start by making sure that there's no repeats just in the rows or just in the columns. And then making sure there's no repeats in the rows and in the columns. And then finally making sure that the 3x3, the big 3x3 square doesn't have any repeats, right? I basically would build it up, make sure that it works for some of the, that you're only checking for the easy things, and then go on to the harder stuff. So, let's see. Yeah, I don't need the password for this. Sudoku. So let's go back to Sudoku. And although the number of people who've spelled it Sudoku is actually quite high, and it's high every semester. I also don't know why my internet's terrible, right? Because it's just been that way. Has everybody else had internet issues today? Always? Yeah, I feel like I need to just hop on eduroam instead. You can do that, by the way. eduroam? EduRoam? Your email, the difference is that your login is just your email. And your password's still your password, but instead of using just your username, you use the email, the TU email that you have. So you have to have the @temple.edu for that. I have no idea. I've had, but I've been able to connect to it when I've not been able to connect to the other one. So I don't know if it's better, but if you're on any of the campuses that use eduroam, you can log in to their you can log in that way. So over here, we've got the Sudoku puzzle, right? And what I was saying is that you want to go ahead and check, maybe just make sure that basically you don't get any repeats in the same row at first, right? So basically your puzzle would work like this. It doesn't care that there's repeats in the same 3x3 square, right, for right now, or the same column. What you care about is not having it in the same row, right? Oh, I missed one over there, so 2, 3, 4, 5, 6, 7, 8, right? So notice that there's no repeats in the same row, right? Although there are repeats in the same column, right? But that's fine, because if you get it programmed that way, and then you get the recursion working, and then you can solve, and then you get this quote-unquote solution. Yes, it's a wrong solution, but so long as you get that working, then you know that basically you've got the recursion working, and now you can focus on the isValid check, which is then you can say, okay, making sure it's not on the same, it's not in the same column, and then the 3x3 mode. Now the 3x3 is actually, the way you can do that is, let's just view this entire Sudoku board as rather than, you view it as two things at once. First as a 9x9, right? As a 9x9 grid, but also as a 3x3 grid, right? So because you want to figure out which of these 3x3 big squares you're in, right? Everybody see how there's it's a 3 by 3 of big squares, right? So what you can do is you can find the top left corner of the big square you're in, and then it's pretty trivial to just iterate through the members of your big square by just saying, okay, this is my row corner, column corner, right? This is row corner, this is column corner plus 1, column corner plus 2, row corner plus 1, column corner plus 0, row corner plus 1, column corner plus 1, row corner plus 1, column corner plus 2, and so on and so forth, right? Basically, you just have a nested loop that goes over, you know, that basically says increment that runs both of the row corner and the column corner from 0 to 2. And that will work. So how do you figure out what 3 by 3 square you're in? Well, the answer is you can use division and then to figure out what that is, to figure out what 3 by 3 square you're in, right? Say we're looking at this coordinate, which is 0, 1, 2, 3. So this is column 3, row 4. So this is 4, 3. If we divide 4 by 3 and 3 by 3, that's equal to 1. So, and if you know, those are both equal to 1. And if you notice, the big square that we're in is 1, 1, right? Okay, so let's keep that in mind. Now, if I'm over here in this square, which is row 6, column 5, right? I divide 6 by 2, so I divide 6 by 3 and 5 by 3, and I'll get 2, 1. And if you notice, this is big square 2, row 2, column 1 for the big squares, right? So you can use division to find out what big square you're in. Now, how do you translate that into the corner over here and the corner over here and the corner over here? I'll leave that up to you, other than to just say use multiplication. Use division to figure out what big grid you're in, and then you can use multiplication to find out the top left corner of where you are in that square. Translate that back to the regular indices that you need. So that's my hint for Sudoku. The last thing so let's go ahead and just